गुड आफ्टरनून एव्हरीवन. विद्यार्थी मित्रांनो, मागच्या तासात आपण मेकॅनिकल प्रॉपर्टीज ऑफ फ्लुइड मधला तिसरा जो भाग आहे हायड्रोडायनामिक्स, त्याच्यामधला एक महत्त्वाचा पार्ट विस्कॉसिटी आणि त्याच्याशी रिलेटेड काही कन्सेप्ट त्या आपण शिकलो, त्याचा अभ्यास केला. विस्कॉसिटीवर आधारित दुसरा भाग आपल्याला स्टडी करायचा आहे. काही लॉज आणि काही इम्पॉर्टंट कन्सेप्ट. त्याच्यापैकी पहिली आहे वेलोसिटी ग्रेडियंट, नेक्स्ट आहे न्यूटन्स लॉ ऑफ विस्कॉसिटी, त्यालाच कोएफिशियंट ऑफ विस्कॉसिटी असं सुद्धा म्हटलं जातं, आणि तिसरा पार्ट आहे स्टोक्स लॉ ऑफ विस्कॉसिटी. हे छोटे छोटे पण फार महत्त्वाचे आर्टिकल आहे. So dear friends, up to our last lecture we study the part of hydrodynamics which was viscosity, its definition, viscous drag, Reynolds number, critical velocity, and how streamlined flow get converted into turbulent flow beyond critical velocity. Such number of concepts we learned in last lecture. Next part we have to learn is few basic concepts and few laws related with viscosity. We know the concept of drag force or viscous force, which is experienced by any object moving in the fluid or it present between different layers of fluid. Regarding the same, we have to study or we have to learn a basic concept called as velocity gradient. So first one is number 1, it is velocity gradient. So what is velocity gradient? In case of a fluid moving with particular velocity, we know that central part moves with faster speed as far as river is concerned, and the river at the bank of river flows with low speed as compared to central layer. आपण मागच्या तासात पाहिलं की एका स्थिर सरफेसच्या तुलनेमध्ये प्रत्येक जो थर असतो त्या फ्लुइडचा तो वेगवेगळ्या व्हेलॉसिटीने मूव्ह होत असतो. जस्ट आपण एक्सप्लेनेशन केलं तर हा असेल स्टेशनरी लेयर, त्याच्यानंतर असे वर काही लेयर असतील, त्यांची व्हेलॉसिटी अशा बदलत जाते अशा पद्धतीने. जसं आपण एका लेयर पासून पुढे पुढे सरकत गेलो तसं यांचे जे व्हेलॉसिटी असतात त्या बदलत जात असतात. हा असेल स्टेशनरी. त्याच्यानंतर हे अंतरानुसार बदलत असेल. सपोज दिस ऑब्जेक्ट और दिस लेयर इज ॲट डिस्टन्स x. Next, this is at distance x plus dx, and before that this is at distance x minus dx. If its velocity is v, its velocity is v plus dv, and this layer has velocity is v minus dv. So it is clear that with change in distance from fixed layer, the velocity of layer also changes. We can say it increases as compared to stationary layer. So it leads to conclude a basic concept called as velocity gradient. What is velocity gradient? This velocity gradient is equal to dv by dx. We can read this as the rate of change of velocity with respect to distance. But distance is measured from stationary layer. So this is velocity gradient. This velocity gradient is defined as the rate of change of velocity with respect to distance. We have studied the acceleration velocity in last year, that is change in displacement with respect to time, change in velocity with respect to time, but this concept is not the same. here it change in denominator term, instead of time it is changing with distance. Just I would like to give one example. If you throw an object from one place, that object fall at certain distance. If we observe closely, as the distance increases, what happens to velocity? That velocity decreases, and that part is called as velocity gradient. एखादा ऑब्जेक्ट जर तुम्ही एका ठिकाणाहून फेकला तर दूर काही अंतरावर जाऊन तो खाली पडेल. जिथं पडला तिथपासून आणि जिथून फेकला तिथपासून अंतर मोजलं, त्याच्यानुसार जर तुम्ही पुढं 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 गेला तर जसं डिस्टन्स वाढत जातं तसं वेलॉसिटी काय होत असते? कमी होत असते. त्याला वेलॉसिटी ग्रेडियंट म्हणायचं. म्हणजे जितकं अंतर वाढलं तशी वेलॉसिटी कमी झाली. एखाद्या वेळेस उलटी होऊ शकते, वेलॉसिटी वाढू सुद्धा शकते. जर असं झालं तर त्याला ते पॉझिटिव्ह वेलॉसिटी ग्रेडियंट म्हणायचं. हे निगेटिव्ह वेलॉसिटी ग्रेडियंट होऊ शकतं, जे आपण अगोदर एक्झाम्पल दिलं, जर चेंज डिक्रीज होत असेल. Similarly, in case of layers of water or fluid flowing with certain velocity, if you measure the velocities of different layer as compared to the stationary layer, it is observed that as distance increases, the velocity also increases. So this concept is called as velocity gradient. So velocity gradient is defined as the rate of change of velocity with respect to distance. Its unit can be taken as velocity, it is meter per second, and again here is meter. Velocity gradient, velocity is measured in meter per second per meter, so it is just, you can say, per second velocity. So it is just like time dimensional formula. So this is velocity gradient. Now second part we have to study is Newton's law of viscosity. This is again a very important law. Newton's law of viscosity. Or coefficient of viscosity we have to study here. So Newton's law of viscosity states that, as we studied earlier, there is force, dragging force, which is present between different layers of liquid in motion. So that dragging force or viscous force is related with certain terms, and it is given by Newton's law. So according to Newton's law, the dragging force, number one, it is directly proportional to area of the layer. Also, the dragging force is directly proportional to dV by dx. So, according to Newton's law of viscosity, the drag force which is present between different layers of fluid, first it is directly proportional to area of the layer, surface of one layer in contact with another layer. Between two layers there is a dragging force or viscous force. That viscous force is directly proportional to area of the layer in contact with another layer, and also it is directly proportional to dV by dx, that is velocity gradient. So this is statement of Newton's law of viscosity, and the constant of Newton's law of viscosity is called as coefficient of viscosity, that we have to obtain here. So first, Newton's law of viscosity states that the drag force which is present between different layers of fluid in motion is directly proportional to area of the layer. It is not area of cross section of the tube. You have to remember this. So this is area of the layer in contact with another layer, moving layer you can say. Also it is directly proportional to rate of change of velocity with respect to distance. It is called velocity gradient. If we combine these two parts, so you can write here, this drag force is directly proportional to area and this velocity gradient. If we are to remove this proportionality sign, we have to introduce here a constant. So here F is equal to eta into area into dV by dx, where this eta is a constant. called as coefficient of viscosity. So you can write expression for eta here. Therefore, this eta can be written as F divided by area into dV by dx. So this is expression for coefficient of viscosity. So here coefficient of viscosity, which is the constant introduced in Newton's law of viscosity. So coefficient of viscosity can be defined as the drag force per unit area per unit velocity gradient. So this is Newton's law of viscosity and relation for coefficient of viscosity. So coefficient of viscosity is defined as the drag force, or we can say in other words viscous force per unit area per unit velocity gradient of that fluid or that liquid. So in short, in simple part, we can write this as eta is equal to capital drag force divided by area into this is dx by dv. Using this relation, we can find units and dimensions. So what is the unit of this? So SI unit of coefficient of viscosity. Force is measured in Newton, is area in meter square into displacement in meter, and this is meter per second. So see here carefully, 1 meter get cancelled. We can write this as it is equal to Newton into second divided by meter. So CGS unit of this viscosity is poise. It is given in your book. We can also write dimensional formula for this. So if we write here dimensional formula, we can write here it is kilogram meter per second square into second divided by meter. So what is dimensional formula? Here you can write dimensional formula for eta. It is equal to kg meter per second square. It is fundamental unit of force. Seconds to the power minus 2, 1 second. Meter get cancelled. Here it is m to the power 1 and t to the power l to the power 0 and t to the power minus 1. So this is the dimensional formula for coefficient of viscosity. So this is Newton's law of viscosity, and the constant which is introduced in Newton's law of viscosity is the coefficient of viscosity, and coefficient of viscosity is defined as the drag force per unit area per unit velocity gradient. Its unit is Newton second per meter. SI unit, it is I think Newton. 1 meter get cancelled. Here Newton per meter square is meter square area. So here meter square is there. So finally you can write here 10 to the power minus 1. See here carefully. Force is measured in force Newton, area meter square, displacement in meter, velocity meter per second. Meter get cancelled. Here Newton second per meter square. And finally Newton is kg meter per second square into second. 1 meter get cancelled. Remaining part is m to the power 1, l to the power minus 1, t to the power minus 1. So this is dimensional formula for coefficient of viscosity. Last one we have to study here is Stokes law. Before that, one important term or important information related with coefficient of viscosity. It is observed that if the temperature of fluid is increased, it affects the coefficient of viscosity. In last lecture, we discussed about the drag force in case of fluid, in case of liquids, in case of gases. In case of liquids, the drag force is due to cohesive type of intermolecular force of attraction. And in case of gases, the drag force or viscous force is due to the number of collisions between the molecules and with the wall of that container, you can say. So if it is so, then with increasing temperature there is change, or it affects the coefficient of viscosity. As far as liquid is concerned, with increasing temperature the cohesive force decreases, and due to which the coefficient of viscosity also decreases. In case of gases, due to increase in temperature, the number of collision increases, and therefore the viscous force, or you can say drag force, increases. लिक्विड आणि गॅसेसमध्ये जसं टेम्परेचर वाढलं तसं इंटरनल स्ट्रक्चरमध्ये थोडासा फरक पडतो, म्हणजे विस्कस ड्रॅग किंवा कोएफिशियंट ऑफ विस्कॉसिटी आपण म्हणू शकतो. जर लिक्विडचं टेम्परेचर वाढलं तर त्याच्यातला इंटरमॉलिक्युलर फोर्स ऑफ अट्रॅक्शन, कोहेजिव्ह फोर्स, ज्याच्यामुळे विस्कस ड्रॅग होता, तो फोर्स कमी होतो. आणि जर विस्कस फोर्स कमी झाला त्याचा इफेक्ट डायरेक्टली कोएफिशियंट ऑफ फ्रिक्शनवर, कोएफिशियंट ऑफ विस्कॉसिटीवर होतो, तो कमी होतो. आणि इन केस ऑफ गॅसेस, ड्यू टू increase in temperature, as the molecules of gas are always in the state of random motion, if their temperature increases, they move violently and collide with their more number of collisions takes place with the neighboring particles. If large number of collisions takes place, means the viscous drag increases, and if viscous drag or viscous force increases, the coefficient also increases. So these are the very important terms given in your book. The theoretical question may be there for 1 marks in competitive exam. So last one is we have to study Stokes law of viscosity. So it is related with motion of spherical object in a liquid. If you consider here the part of liquid, suppose this is the part of liquid and a spherical object is fall into this liquid. It is moving in downward direction. Initially the liquid's layers, we can say they are parallel. As this sphere moves in downward direction, this is moving in downward direction, like this. These are the flow lines, you can see. In last lecture we have discussed about them. So these are the flow lines, and that spherical object is moving in downward direction. It experiences a force in upward direction. This is called force due to viscosity. It is moving in downward direction. Its velocity actually is in downward direction, but it experiences a force which is in upward direction. Force of friction, force of viscosity due to the liquid. And it is observed that the force of viscosity or viscous force, according to Stokes law, this viscous force Fv is first directly proportional to radius of that sphere. Second, this viscous force is directly proportional to velocity of that sphere which is moving in downward direction. And third one is this viscous force is directly proportional to coefficient of viscosity. So this combinedly called as Stokes law. So according to Stokes law, if a spherical object is allowed to fall in the fluid, viscous fluid you can say, it experiences a drag force in opposite direction and that viscous force acting on the spherical object is number 1 directly proportional to radius of that sphere, number 2 velocity of that sphere in downward direction, and number 3 the coefficient of viscosity. If we combine these 3 parts together, therefore this viscous force is directly proportional to eta, radius and v. If we replace this proportionality sign by constant, here it is considered that empirical constant is taken there. So F V, force due to viscosity, we can say it is equal to 6 pi into eta into r into v. So this is the Stokes law or formula using Stokes law, where 6 pi is empirical constant. It is observed or it is calculated by Stokes in case of fluid, any object moving through the fluid, especially for spherical object. So it is Fv is equal to 6 pi eta into rv. मागच्या तासामध्ये आपण एक फिगर पाहिली होती. एका पात्रामध्ये ऑइल आहे, दुसऱ्यामध्ये हनी आहे, मोहळाचा मध आहे, तिसऱ्यामध्ये पाणी आहे आणि एक स्पियर त्याच्यात पडला. तर सर्वात अगोदर कोणता स्पियर तळापर्यंत पोहोचला? तो पाण्यामधला. याचा अर्थ पाण्याचा विस्कस ड्रॅग हा कमी आहे कंपेअर टू हनी अँड ऑइल. सर्वात शेवटी कोणाचा? ऑइल मधला. याचा अर्थ ऑइलचा विस्कस फोर्स जास्त आहे. तो जो फोर्स असतो तो कशा डिपेंड आहे? स्फेरिकल ऑब्जेक्टच्या रेडियसवर. जितका मोठा स्फिअर घेतला तितका फोर्स मोठा होईल, त्याच्या कॉन्टॅक्टमधला एरिया वाढत जाईल. त्याच्यानंतर वेलॉसिटी आपण पाहिलं टर्ब्युलंट फ्लोमध्ये विस्कस ड्रॅग जास्त असतो. त्याचा जर वेग खूप वाढला तितकं त्याचा ड्रॅग फोर्स जास्त होईल. आणि कोएफिशियंट ऑफ विस्कॉसिटी, ज्या लिक्विडचा कोएफिशियंट जास्त असेल त्याचा विस्कस ड्रॅग सुद्धा जास्त असेल. तर हा झाला स्टोक्सचा लॉ. यांचा वापर करून आपल्याला पुढचं टर्मिनल व्हेलॉसिटी आणि त्याचं एक्सप्रेशन बघायचं. तर या तासामध्ये पाहिलेल्या महत्त्वाच्या कन्सेप्ट: व्हेलॉसिटी ग्रेडियंट, रेट ऑफ चेंज ऑफ व्हेलॉसिटी विथ रिस्पेक्ट टू डिस्टन्स, सेकंड न्यूटन्स लॉ ऑफ विस्कॉसिटी और कोएफिशिएंट ऑफ विस्कॉसिटी, फोर्स ड्रैग फोर्स डिपेंड्स अपॉन एरिया इन कॉन्टॅक्ट विथ डिफरंट लेयर्स अँड व्हेलॉसिटी ग्रेडियंट. त्याच्यावर आलेला कॉन्स्टंट आहे कोएफिशिएंट ऑफ विस्कॉसिटी. त्याचे युनिट आणि डायमेन्शन्स व्यवस्थित आपण स्टडी केलं. त्याच्यात जी चूक झाली ती दुरुस्त केली लगेच. आणि तिसरा पार्ट इज स्टोक्स लॉ. नंतरच्या तासामध्ये इन नेक्स्ट लेक्चर वी विल स्टडी और वी लर्न अबाउट द टर्मिनल व्हेलॉसिटी, very important relation regarding this viscosity.